Alright guys, welcome to Math 0314. This is section 4.7, factoring binomials. And what we're going to be talking about here is an extension of what we talked about earlier, which is called the difference of squares. And the difference of squares is essentially what I'm writing here, which is anytime you can take this, anytime you have a value that is squared plus minus another value that is squared, we said it again, a value that is squared minus a value that is squared, it can break down to the square root of those, plus or minus. Now, in action, this is a lot easier to actually see what's going on. So what I'm saying is that because I can take the square root of both 16x squared and 9, I can rewrite those as plus and minus, and they would be equivalent. In other words, the square root of 16x squared is 4x, the square root of 9 is 3. And if I write that twice and put plus or minus, we have what it would factor out to be. And you could FOIL this back out, and you would see that you would clearly get the same thing, because the middle part, because you're going to be getting negative 12x, and then 12x, they're going to cancel out. So all you're left with is 4x times 4x, which is 16x squared, and 3 times negative 3, which is negative 9. And this is another thing that's really important to realize, which is that if you can go one way, you can go the other, right? So it's very easy to check your work, and I would encourage you on an exam to do so. But that's all that the difference of squares is saying. Very important, very useful. Let's see another example. So here we have 4z squared minus 1. So again, because I can take the square root of both of these, and there's a minus sign, this breaks down to the square root of 4z, which is 2z. The square root of 1 is just 1, plus or minus. And the order doesn't matter. It could go plus, minus. I think in the previous video, plus and minus as well. The order doesn't matter. Okay, let's keep going. So here, we have a little bit of a problem, because if I try to take the square root of 98, it doesn't come out pretty. And this also has a c squared d, and then we have the 50d cubed. But just like in the previous section, what we always want to try to do first before we attack any problem that deals with factoring is just try to factor something in common. So I see 98 and I see 50. I easily notice that they're both divisible by 2. And I also notice they both have a d. So I'll factor out a 2d. This will become 49c squared minus 25d squared. Okay? So again, let's just be clear here. 98 divided by 2 is 49. The d's would divide out. 50 divided by 2 is 25. And then we would lose one of the d's. Okay? So once we're here, what I want to do now is realize I've created the situation of the difference of squares, because I can take the square root of both of these, right? Which would be 7c and 5d, and we can put plus and minus. And there you have it. So, more of the same. You always want to try to factor first if they have something in common. Let's look at the next one. So, this is one that you should be able to do on your own. Pause the video, give it a shot, see what happens. And I'm assuming that you've done so. And I hope that you noticed early on that both of these are divisible by 7. Both of these are divisible by y, and both of them have a z in there. Right? So once more, you can take out the lowest letter. The lowest number of letters. Right? So 7yz goes on the outside. And when we divide this, we're going to be left with y squared. Here, 63 divided by 7 is 9, and we're going to be left with z squared. Once more, we see we have here the difference of squares, which breaks down to y plus 3z, y minus 3z. And I hope you can tell me why, and I hope your answer is that the square root of y squared is y, and the square root of 9z squared is 3z. We write it down twice and plus or minus. Moving right along. On this one, don't let the z to the 4th scare you. You can still take the square root of that. One thing that's important here to realize is that when we take the square root is a fancy way of saying we're raising it to the 1/2 power. So all we're saying when we take the square root is that we're going to divide the exponent by 2, which would give me z squared. So this breaks down to z squared plus 9 and z squared minus 9. Remember, the square root of 81 is just 9, right? Now, a lot of students stop here and they say, that's my answer, and I'm done. But we can continue the process here because z squared minus 9 breaks down to z plus 3 and z minus 3. This is very much a test-like question. What they're going to say is they're going to say factor out completely, and they'll leave this as one of the answer choices, but we have to go all the way. So just be very careful. If you can break it down some more, go ahead and do so. And once again, I want to stress that you can always, if you foiled this whole thing out, it would take you back to z to the fourth minus 81. So go ahead, if you haven't done so already, pause the video, try number 6, give it a shot on your own. And I'm going to assume that you've done so now, and then we can go over it together. So more of the same, we'll take the square root of both of these, we'll get b squared plus 4, b squared minus 4. And once more, b squared minus 4 breaks down to b plus 2, b minus 2. So maybe looks a little intimidating initially, but if you can just remember to take the square root and just keep taking the square roots, as long as you have a minus, right, you should be fine. Let's take a look at number 7. So 7 looks a little scarier, but we're going to apply the same sort of strategies, right? So first thing we notice, we see 4 terms. So from the previous video, I hope you realize that this is probably going to be a situation of the difference of squares, right? I'm going to first look at this to see if there's anything you can take out in common to all the terms. There is not. They don't all have a's, and if the leading coefficient is 1, there's not really much I can do. So I'm going to consider this into 2 cases. I'm going to take both of these and break them down, factor out as much as I can, and then compare. So in the first one, I'm going to take out an a squared, and I'll be left with a plus 5. I hope that's apparent. The second one, I'm going to take out a negative 9. Watch your signs. You're going to get a plus 5. And now we've created what we want. We have an a plus 5 in common. So we'll factor the a plus 5 on the outside. But the new twist is that we're not done yet once we get here, right? We realize now that a squared minus 9 breaks down to a plus 3 times a minus 3. So we're here. And hopefully that makes sense. So, taking the same notions that we've learned from the previous classes and applying them. Okay. I hope that this also illustrates to you that it's very important that you understand each of the previous concepts. All we're really doing in each of these lessons is tackling on one little bit more. So, go ahead and pause the video, try this one on your own. I'm going to assume that you've done so. And once more, we try to factor out any terms that are in common with every. We're going to factor out something that is common to every term if possible. There is not. They don't all have y's. The leading coefficient is 1, so that means that you can't factor out any numbers. So we're left to pairing these. And so we'll take out a y squared, which leaves me with y minus 6. Over on the back side, we're going to take out a negative 4. Watch your signs, y minus 6. And this is usually what ends up happening. So we see we have y minus 6 in common. We factor that out. We're left with y squared minus 4. Y squared minus 4. Again, once just like in the previous example, we can factor that out too. Y plus 2, y minus 2. And then we also have y minus 6. Alright, now in this situation, again, we try the same initial step. We see if we can factor something out of everything. Hopefully now, realize that in this situation you can't. So we group them again. But this one starts off with the difference of squares here. So we know that this becomes x plus y, x minus y. And on the other side, we can factor out a negative 3, which leaves me with 2y minus 3. Now, there's nothing that these have in common, so it seems that we can stop here, but let's play with it a little more. Let's rearrange some things. Let's put, let's try x squared minus 6y and negative y squared minus 9. And see if there's anything we can do here. Well, we can't break this down, If we factor it out a negative, this would become y squared plus 9, which means I can't do anything with that, so no. Okay, so we've tried putting the y's together, and then we've got one last option to try, which is that we'll put x squared minus 9 together, and then we'll put negative y squared minus 6y together, and this will break down to x plus 3, x minus 3. We can factor out a negative, but that's just y squared plus 6y. So we exhausted all options, nothing works, and when that occurs, we can say it's prime. Moving right along. Okay, we're going to try the same thing. We will try to factor... Wait. I apologize. There may be one more move that we can make, and there is. So, there's one other situation that can occur here. Maybe it's not prime. Let me rewrite the same value, x squared minus y squared minus 6y minus 9. And this last option is that if I factor out a negative, I get y squared plus 6y plus 9. Now, with this factors into y plus 3 squared, right? And if you don't believe me, take y plus 3 times y plus 3, and you'll realize you'll get 6, and then 9, which represents these values, and this is minus x squared. So what we can do here, I apologize, it is not prime, is that we can take, now this represents the difference of squares, so this breaks down to x plus y plus 3 and x minus y plus 3. And that's a little unclear, so let's realize we take the square root of this, that's x, square root of this is y plus 3, plus or minus. We're going to rewrite this as x plus y plus 3, and this is x minus y minus 3. Okay? So that was a little tricky. That process continues here. So if we look at this, we can break this down to x plus 5 squared minus y squared. Notice here that what I'm seeing is that 25 is 5 times 5, and 5 plus 5 is 10. That's how I'm so quickly being able to break that down. Again, you can take the square roots of both sides. We have x plus y, and then we have x minus 5 plus y. I'm sorry, I wrote that down wrong. X plus 5 minus y. And what was tripping me up, and the reason why I made a silly mistake, and I should always do this, apologize for not doing that, that's quantity squared, right? And then we can break it down to x plus 5 plus y and x plus 5 minus y. Apologize for that, but there you have it. So hopefully that's okay. Number 11, we have a different situation here. We notice that we have a cube here. So this is known as this difference of cubes, and this formula is given a cubed minus b cubed. This becomes a minus b times a squared plus ab plus b squared. Okay, and though it doesn't apply here, there's also, for this one, the sum of cubes. And this breaks down to as such. So you'll see that there's a similarity between these, and they're the same, they're the difference, and they're positive. So they follow initially the same, right? Then the signs switch here in the middle, and then it's positive. So same, different, positive. Some people memorize this as San Diego Padres. Another way this is sometimes called is called SOP. So same, opposite, positive. Whatever works for you. But my recommendation is figure out what the pattern is. And the pattern here is this. Let me write it. It's x cubed minus 27. So all you have to do is first rewrite this as this cube root, so x minus 3, If you're confused here, remember cube root just means you're multiplying by itself 3 times. And so 3 times 3 times 3, 3 times 3 is 9, 9 times 3 is 27. Okay, then in the back part, you're going to square each of these. So this becomes x squared. This becomes 9. And in the middle, it's the product of the two, 3x. If the first one's negative, then the second one is positive, and the back one is always positive. And there you have it. So, see if that makes sense. Go ahead and pause the video. Try this one out on your own. I'm going to assume that you did so. And again, I'm not even going to write the formula out. All it is, I'm going to take the cube root of both of these. Okay. If you're confused with the fact that 2 is the cube root of 8, again, 2 times 2 is 4. 4 times 2 is 8. Then we're going to square both of them. And then we're going to take the product of these two, which is 2x. We're going to remember it's the opposite, and the back one is always positive. And that's it. Let's keep going. 13, trying to scare you with having a leading coefficient other than 1. But it's the same thing, so go ahead, pause the video, try it on your own, see what you get. Going to assume you've done so. We're going to take the cube root of both of these. This is going to break down to 2x minus 3. We're going to square 2x. Now this is the part where people make mistakes. This is going to give you 4x squared because you have to square both of them. The back is going to be 3 squared, which is 9. The middle is the product of the two, 6x. And remember, we have the same opposite positive, or same different positive. Okay? Moving right along. Again, this one you should be able to do on your own, so pause the video, see if you can. I'm going to assume that you did so. So we're going to take the cube root of both of these. We're going to get 5p minus 2. Hopefully in time, too, you are becoming more and more aware of cube roots. And what I would do is create like a little list as they pop up, write them down. Again, don't try to formally memorize them, but just be on the lookout for them. And you'll naturally start to memorize them. At least that's what I did, and now I know them by heart. So square both sides. Remember, this is going to be 25p squared. Got to square both. The back side square it, you get 4. The middle is the product, which is 10p. Same, different, positive. Over here, more of the same. They're trying to scare you with the 7 to the 6, but it is more of the same. So go ahead, pause the video, attempt this on your own, and then we'll talk about it. I'm going to assume you've done so. Just recall that when I said you take the cube, the square root was 1/2, so the cube root is the 1/3. So when you do this one, you're going to get 5x plus the cube root of 64 is 4. The cube root of z is 6 is z squared. Okay, because 6 times 1/3 is 2. And then we're going to break these down. So we're going to square both of these. Okay, we're going to get 25x squared. The back part, be careful in the back one, 16z to the 4th, because we're squaring it, and the middle is the product of the two. So it's going to be 20xz squared. Same, different, positive. And there you have it. Alright, the next one is actually, even if it looks a little intimidating, it really isn't. It's more of the same. So once more, pause the video, give it a shot, see if you can figure it out. Hopefully you figured out that this was going to be x and 10y squared, right? Cube root of x cubed is x. Cube root of 1,000 is 10. All you have to do is count the zeros. And the cube root of y to the 6 divided by 3 is 2. The middle part's going to break down to x squared x squared minus 10x y squared. And the back is going to be 10y squared, which is going to be 100y to the 4th. Moving right along. I'm trying to scare you with fractions. This was actually easier than the other ones, because if you take the cube root of 1 over 8, the cube root of, so let me write that out. The cube root of 1 over 8 just means you're taking the cube root of 1 over the cube root of 8. You don't have to write this out every time, or even on this one. It's just going to give you 1/2. So this is going to become m minus 1/2. Square both. The middle is the product of the two, which is 1/2 m. And that's it. Alright, so we see this one, 9k squared plus 24m squared, and you have a problem on this one initially. Hopefully. You see that, 1, we're back to squares, and 2, you can't take the square root of 24. So what do we have to do? Well, we can factor out of both of these. These are still both divisible by 3, so let's try that and let's see what we end up getting. So this breaks down to such. Can we do anything with this? No, we can't. So this is it. This is as far as we can go here. There's nothing more we can do. So let's see on this one. So we see that they both are divisible by the minimum 2. Maybe more. Maybe we don't see it initially, but let's take 2 out. So we take 2, we get 64 y to the 6 plus, now 50 divided by 2 is 25. 54 is going to give me 27 z cubed. Now this is interesting because 64 is 4 cubed, 27 is 3 cubed. Again, in time you should be able to realize that, and hopefully you're writing these down and having a sheet off to the side of what your cube roots are, so you're writing something out like 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. These are the ones that we've seen thus far. And so that you're recalling them, and it becomes easy to memorize over time. We can't take the sum of cubes here. So remember, the sum of cubes is take the cube root of both of these. So the cube root of 64 is 4. The cube root of y to the 6 is y squared. The cube root of 27 is 3. The cube root of z cubed is z. And then we just rewrite each of these squared. So that's 16y to the 4th. The back is 9z squared. The middle is going to be 12y squared z. Now, can you catch what I did wrong? Hopefully you noticed that the same different positive, so this should be minus. Okay? Take one last look, see if there's anything else that can be done. Doesn't seem like it, so this is our answer. Alright, so more of the same here. We're going to say, what can we factor out of 50 and 8? Clearly they're both divisible by 2. So we'll take a 2 out, and this leaves me with 25 y to the 6 minus 4x squared. And then realize that this is not the difference of cubes, but we can take the square root of both of these, so we can go ahead and do that. That's 5y. Remember now, we're dividing by 2, so this will be y cubed. We're going to divide 4 by 2, and that's going to give me 2. I'm sorry, let me rephrase that. We're taking the square root, so this will give me 2x. I want to write it down minus plus, well, I'll go plus minus. Sorry, my mind was in 2 places at once. Okay, so well, that makes sense. I took the square root of this, got this, took the square root of this, got this. And then we're going to take a look here and see if they can break these down anymore. It doesn't seem so, so we're just going to move on to the next one. Alright, so this one is interesting. I think you actually can figure it out on your own, so pause the video, try it on your own. Hopefully you did so and you figured it out. This one, I'm going to take we can actually do it 2 ways. We could do the difference of squares, or we could do the difference of cubes. I'm actually going to do the difference of squares first. So this becomes x cubed plus y cubed times x cubed minus y cubed. And hopefully you can see that if I take the square root of each of these, right, means I'm raising to 1/2, they're going to be 3's. Okay. Now each of these is the sum and difference of cubes. So this is going to be x plus y times x squared minus xy plus y squared. Literally it's the formula, and the same thing's true on the other one. So x minus y, x squared plus xy plus y squared. And there you have it. Super interesting stuff there. Alright, last one, guys. Y'all know what to do. Go ahead and have fun with it, and we'll talk about it in a sec. So, most people will look at this and realize you do have the difference of, you can either go the difference of squares or the difference of cubes. I'm going to go with the difference of squares. This is going to be a cubed minus, I was going to say plus 8. I'm sorry, I'm doing the difference of squares. Yeah, no, that's still correct. Plus 8 and a cubed minus 8. Apologize. So let me be clear here. The square root of this is a cubed. The square root of this is 8. So write them down plus or minus. But these are just like the previous ones. You can take the sum and difference of cubes. So we'll go ahead and do that for both of these. So the first one's going to break down to a plus 2. The cube root of a cubed is a. The cube root of 8 is 2. This becomes a squared minus 2a plus 4. The other one's going to be basically the same thing, except the signs are going to be switched for the first part. So what I'm saying is these two signs, notice, are the opposite of these two. But that's essentially it. And there you have it. So, just a reminder, you need to know a squared minus b squared equals a plus b times a minus b. And you also need to know a cubed plus b cubed is a plus b times a squared minus ab plus b squared. And a cubed minus b cubed is a minus b times a squared plus ab plus b squared. And if you have these formulas down, then anytime you see these situations, it's pretty straightforward on how to solve them. One last comment on this, just want to make sure, understand that if you have something like x squared plus 9, this is prime. This is not the difference of squares. There is no such thing as x. When you see this, to say something like x plus 3 times x plus 3, right? Because if you do this, you're going to get a middle term of 6x. Right, you would get this actually. So this does not exist. Don't worry. Don't get that confused. But if you know these three formulas, this section should be fairly simple. My advice to you is, if you struggled initially through it, go back through, rework the problems, see if you can get them on your own. So I've said enough. Hopefully this makes sense, and I will see you guys in the next video.